So far, I've shown you how to load the data and make graphs with two different options. And for that, I have used Victoria's data of stress granule induction by arsenite. One thing I did not address or commented on was the presence of these two dips in the curves. They are due to wash steps when the plates had to be taken out of the imaging chamber. I'm going to address how to correct for those dips in another video, but for now I want to show you how to make modifications to a graph and do some other simple calculations such as averaging and normalization. And I want to do that using a heat shock data from Racciata. That would be a nice quick repetition of the steps of the workflow. So I'm going to make a new experiment for that. This window browser stays open, but we can close it for now. The first thing is to load the procedure file. And then load the metadata first. And then load the cell profiler output. As you can see, not all of the 96 wells in this plate were imaged. As I said before, we have two options for making graphs. The first one makes a graph of one measurement for all of the wells of the selected row. So let's say that row is E, and I'm going to select partition, coefficient. One thing you're going to see in experiments where not all of the 12 wells were imaged is this error message, because the code was constructed expecting all 12 wells in particular row. But this error message is benign. You can just close and ignore it. I'm going to select these E wells by Control C, and I'm going to make the curves using the second option or second function. Type in the selected wells, and then I'm going to select all measurements. Now we should have 6 different graphs for the selected 7 wells. I'm going to go ahead and close the enrichment coefficient, as there is not much useful information there. And the first thing I want to point out in one of these 3 graphs is this unusual dip. So whenever you see an anomaly like that, you should go back and check the movies to see what's going on. Well, actually, a good practice is to play back the movies and consult with the graphs all the time. So there was some dip in E11. Let me make the curves thicker so that you can see better. So in order to modify the curve look or type or anything on the graph, we recall this modify trace appearance window, which is again right click on the graph area, modify trace appearance. So you can select and change any of the attributes for one curve. If you want to change one thing for all of them, you can select all by by holding the shift button, or Control A works as in all Windows applications, and then you can change that one parameter that you want to modify. In this case, that's the size or thickness of the lines. So now the curves are visible a little bit better. So the well 11 is something going on there. And while we are at this making modification to graph, let's say I want to make the same modification to other graphs as well. I could go into each one of them, right click, call this, and repeat the operation. Or there is another way to perform this operation a little bit faster. So if you want to do the same thing for multiple windows, then you can recall that command, which is the one that I just highlighted, and execute it from the command line. So selection could be just by using the mouse, or you can use the up arrow in your keyboard, which can select the particular line from the history. And if I hit enter, it recalls that function or that command to the command line. Then if I hit enter one more time, I'm going to execute that for this selected graph. So I can select the graph, come here, recall, select this one, come to the command line, recall, and perform. So that is a tip to perform the same operation on multiple objects or on multiple windows. Now, I want to make another point, which is about puncta density measurement. As you know, we do this in two different ways. One is by dividing the number of puncta by the area of the cells, which is we call puncta density by cells area. And we can calculate this by dividing the number of puncta by the signal of the cellular area. So in both cases, it's puncta density, but one is normalized by the area of the cells, one is by the signal of the cells. I guess in ideal world, these two measurements should behave similarly, but that is the case here. As we see that in puncta density by intensity, some of the curves or wells are kind of grouping together, but we don't see that kind of obvious grouping in puncta density by cells area. But inherently, these two measurements are a little bit different. One is less sensitive to changes in focus, and that would be puncta density by cells intensity. And puncta density by cells area is insensitive to errors in segmentation. Even if you grab a little bit larger area that includes the background, that may not cause any difference for oh no, that will cause difference for the area, but it will not cause much difference when you calculate the intensity, because background will be very low. So these two have a little bit different responses to imperfections in segmentation and in deviations in focus. So again, it would be useful to check the movies and see what is going on, see if there is any errors in those steps, or these changes are actually legitimate. Maybe there is some inherent property of the cells that displays in such way. So now I want to use this graph to show you averaging. As I said, the wells 9 and 10 kind of behave similarly here, and wells 7 and 8 behave similarly. I'm going to treat them as replicates of the same condition and show you the averaging tool using those. So as our window browser tool is a good friend, so I'm gonna hide all of them to keep my work area uncluttered. Display this graph, and I'm gonna use this to show you averaging. Averaging is done by calling this built-in function or package, which is under Analysis, Packages, Average Waves. And this panel or package have several options for averaging. It can average all of the curves from this top graph, which is the default case, or you can actually specify the waves you want to average by the name, or you could have a table with waves and you could use that for averaging. Because each wave can be actually displayed as a table, so the quickest example of that would be just right click on one particular curve or wave and then edit. So as you can see, that curve is a curve of puncta density by intensity for E10 versus time axis. So imagine having multiple waves in a table and you could use that for averaging, but that is for another time or optional. So right now we're going to use the curves or traces from the graph. But I don't want to average all of them. So I could actually specify the names here, but there is a little bit easier way. And that way is to create multiple copies of the graph, which can be done by hitting Control D. So I'm going to create 2 extra copies of the same graph. It's good practice actually to keep one graph intact as original, just in case modifications you make to the duplicates are not something that you want and they are not reversible. So now from this I'm going to remove the waves I don't want to be included in averaging, and I can do that by right clicking, selecting remove from graph, and in one of them I'm going to leave only 9 and 10 and remove all the others. And this one I'm going to leave, I'm just selecting them by holding the control button. So blue highlighted one's going to be removed. Now I have 2 graphs with 2 different curves in them. Select this one. Let's give it some meaningful name. So it is PD by cells intensity. This is 7 to 8 underscore average. I'm gonna use the same base name for the error wave. Paste here and then ERR. There are 3 different options for averaging. By standard deviations, you can select how many standard deviation to use, or confidence interval, or standard error. Let's choose that. And this option here, if it's checked, then averaged curve is going to be added to the same graph. If it's unchecked, then it won't be added. So by pressing do it button, I'm going to execute the averaging command. However, the averaged curve is not displayed. If I hit this new curve, then I'm going to display the averaged curve like this. Now I'm going to select the second window and perform the same thing. I'm just going to change the name here to 910. Okay. And do it, new graph. So there we go. So now we have average curve for this and average curve for these 2 traces or curves. Now let's say I want to display these 2 averaged curves together. Easiest way again would be to create a duplicate of one of them and then adding another trace or curve to this. But just for learning purposes, I'm going to show you how to do it from scratch. Let me close this package for now. I can recall it anytime I want. So if you were to do a new graph from scratch, you would do it here. Windows, new graph, and then you would select the wave for the y axis and a wave for the x axis. So in our case, that wave is, let's say, this one. For the x wave, we're going to use the option calculated because the time information is already embedded in the wave itself. Because in Eager Pro, even one-dimensional waves are kind of two-dimensional. They have an index part in them, and that index part can contain the wave scaling information. So that's why we don't have to plot these against any time axis, but plot them against calculated x values. So that would be a new graph for the average of 7 and 8. As you see, this curve does not have the, it's for this one actually, does not have the error bars. And error bars can be displayed by modifying the curve. Right-click on the graph, modify trace appearance, select the error bars, and when I do that, this window pops up and lets me to choose how to display the error bars. So in our case, that would be plus minus an error wave. And I'm going to select the associated error wave. The option is plus minus, so I don't have to choose for both minus and plus parts separately. And if I hit OK, now I have the curve with error bars as well. So now to this, I'm going to add the second curve, and I can do that by going to Graph, Append Traces to Graph, or I can do it from the graph itself. Again, right-click, select Append Traces to Graph, and I'm going to select the second averaged wave. There we go. And I'm going to go and display the error bars for the second one as well. Plus minus wave, and my wave is this one. So that error bar display command is already selected here. Without closing the window, I'm going to change the color of one of the waves as well. So let me change it to blue. And let's say I want to change the thickness to 2 or 3. There we go. So now we have both of them in one graph. I can right-click and add annotation. There are a couple of different options for annotation. One is text box, which is you can just freely enter any text, or you can select legend, which automatically puts the wave names and associated colors as a legend, so it's easier to kind of keep track of things. Also, since we made this graph new, the x-axis and y-axis don't have labels. You can double click on the axis, come here and enter the labels, and you can go to the left, do the same thing. So this would be by sales intensity in arbitrary units. The other modifications you can do is, for example, changing the number of ticks. Instead of selecting 5, you can select more. Do the same thing for the left. Also, you can turn on the grid, like such, for the Y and X. There you go. So all of the modifications options are there. So now the last thing I want to show you here is the normalization. Because while we clearly see the difference in max values, it is hard to appreciate the differences in the kinetics. So if we normalize them by the max value, then it will be easier to see. So, and in order to do that, I need to find out the maximum value. And I can easily do that by executing a command called wave stats. And where is my wave? So this is the wave, one of them. Control C, Control V. So now this command now is showing me the whole bunch of statistics for this selected wave. But there is another way to look up the statistics quickly by using this data browser tool. From the list, I can select the same wave, let's say 9 and 8. So if you can see all of the statistics that I need, I'm looking for are already calculated and present. So instead of executing this command, I can come here and then look it up. So the max value for this particular wave is 177.546. So I'm going to use that for normalization. So I'm going to select the name of the wave, equal name again, and divide by 177.546. So now that averaged wave has been normalized by max value, but we need to normalize the error wave as well. So I'm gonna repeat same thing for the error wave. And now I need to do that for the average of 7 and 8. I'm gonna change the name. The max value for that is 121,687. 121,687. And as before, I need to repeat it for the error waves as well. Now, both curves are normalized. Now you can appreciate the differences in the kinetics a little bit better. So I think that's it for graph modification and averaging and normalization. You can just play around, learn about Eager Pro in general, or about the operations I just showed you more on your own.